So we have seen about the reactivity series. We have seen about the reactivity series, and in that reactive series, we have seen that metals, those are arranged in like this, top to the bottom. So suppose here it was your first potassium was there, then second was your sodium, then like this calcium, magnesium, and then in middle you see their iron was there, correct? Then zinc, lead, copper. These were substances. These metals are there. They are not highly reactive and not directly. We can say they can't react vigorously. As well as these substances are not reactive, reactionless. They are reacting with oxides, their sulfides, or anything there. Whatever environmental factors are there, like as oxygen, it can react with it and it form the oxides. So, what are the moderately reactive metals? The metals in the middle of the reactivity series, such as iron, zinc, copper, lead, are the moderately reactive metals. And usually, what happen? All metals, those are found in the form of their sulfide salts or carbonate. But it is easier to obtain the metals from its oxides rather than the sulfides or carbonates. So therefore, if sulfides are present, then these sulfides we have to start hit strongly, and then okay, good. Then we'll get there into oxides, and then these oxides, it's called, this process is called the roasting. When sulfides are converting into oxides with the help of strong heat or temperature, that is called roasting. Remember this definition. There is a difference between roasting and calcination. Yesterday only we have seen about the calcination. Carbonates ores are strongly heated in the limited supply of air to transform into oxide. This process is called the calcination. And when sulfides ores are strongly heated in the abundant air, see that in the abundant air there is no limitation of air how much we are going to apply here. So this process is called the roasting, and where we are taking the limited air, that process is called the calcination. Now here you can see there one example given there, roasting and calcination. See, zinc sulfide reacts with 6 oxygen atoms, and then it gives us zinc oxide plus sulfur dioxide. But here you can see directly zinc carbonate. Here it didn't given there how many oxygen atoms used. Directly it gives us zinc oxide plus carbon dioxide. Okay, so this means this is in calcination process. There is a limited air required, not abundant air. And in roasting method, we require their abundant air. Okay, did you got it? Yes or no? Speak something, all of you. Apurva,
Yes, sir.
did you got it? Yes or no? Okay. Now here, the zinc oxide is obtained, reduced by the zinc by using suitable reactants such as the carbon. When we have to obtain zinc from zinc oxide, see, just we have seen in the process calcination, there we have taken zinc carbonate reacts with the air, but it's limited air, it formed the zinc oxide plus carbon dioxide. And we obtain there, we require just zinc, pure zinc. That time we have to use that reactant. It is a carbon, and then zinc oxide reacts with the carbon. It gives us pure zinc plus carbon monoxide. Means this gas is released from it. Okay, you got it? Yes or no? You should speak something. It's very easy.
Yes, sir.
Okay. So now, not only the carbon, there are so many reactive metals like as sodium, calcium, aluminum are also used to like as a reducing agent here. Okay, reducing agent means what? Suppose they are metal oxides. From that we can obtain the original metal. Okay, so many times we are getting the iron oxides, and from iron oxides also we can obtain this metal, and this process is called, that process is called either calcination or roasting. If they are required their abundant air, then it is a roasting, and if it's required their limited air, then it's called the calcination. Okay. Now, one more example is given here. MnO2 means what is their manganese dioxide reacts with the aluminum. It gives us manganese, pure manganese metal, and L2O3 means what is their L2O3, will tell me its name? Aluminum oxides. What is it? Aluminum oxides. So some substances are given here. You can see here the Fe2O3 plus twice air means here ferrous oxides reacts with the aluminum. It gives us ferrous means iron and aluminum oxides plus heat. Now methods used for the welding rails. Have you seen welding machine that people are joining two metals? Suppose that iron metal, maximum time we are joining it by this welding method. So what is your first process? You will see there hot steel from the thermite reaction here. Slag crucible, and then you can see here transfer section of the rail is where we have to join that part is the transfer section, and then they are molding it with the help of this thing, and then we are getting a slag weld. Okay, both joined there. So due to that reason, we are getting that rail track is there fully one only type of a rod. Okay, it is only made up from one only rod or one only that slag is there. Okay, understood? To see here reaction extraction of less reactive metals, which less reactive metals just we have seen in that same reactivity series. Last materials were there, which were there, gold were there, then silver, gold, silver, and copper. So this you can see, this gold it does not react with anyone. Silver is also there, but copper is formed. This means gold and silver we are getting in the pre-in nature. You know this for obtaining gold, we have to do their mining. Okay, a lot of mining, then this lot of soil we have to remove, and then we are getting there some gold. Okay, due to that its cost is high. Okay, then here we are getting so silver, gold, platinum, these are in nature, and this copper we are getting in with the help of this means in the impurities like the copper sulfides. So this copper sulfides reacts with the oxygen, means in the calcination process or roasting. Which method can you tell me? Thrice O2, here calcination or roasting. Which method will be here? Here roasting method is here. Yeah, very good. So with the help of roasting method, we'll get their cuprous oxide, okay, or copper oxide, and this sulfur dioxide will be released, and then this copper oxide reacts with the copper sulfide, will get their copper. See that copper oxide reacts with the copper sulfide, and then we'll get copper. So like this extraction of less reactive metals we have seen. Now refining of metals. What is the refining of metals? Can you tell me? Refine. Have you listened to the word refine? Refine means here you have listened about the oil. Okay, eating oil, you know that. Okay, they are double refined, triple refined, like this. They are written on that whatever their bags or whatever their we can see that boxes. So refining of metals means from impure metal we have to obtain the pure metal. That process is called refining. Means refining is there by various processes like as a reduction described, not very pure. They contain their impurities we have seen. Metal contains their impurities like as sulfides, oxides. Okay, other impurities we have seen the soil, then sand, rock. These all are the impurities. Then we have to separate from it, and then when they are present with their impurities, that time we have to use their electrolysis method. So electrolysis method, we know this method with the help of electricity to obtain the pure metals. With the help of electricity to obtain the metals, and that process is called the electrolysis method. Now here, corrosion of metals. What is meant by corrosion? Will tell me. What is meant by corrosion? Anybody knows it? Sarta, Alicia, yes, Pranjal.
Corrosion is the degradation of a material due to reaction with its environment.
Very good. Another, anyone want to tell? Apurva, Sarvajnya, Sweta, Yashwat. So corrosion, I will tell one example, you will get easily. Suppose you have seen you have kept one metal rod like an iron rod, open place, And after a few days after rainy season, you can see there it's become the reddish color. Its color is changed. So these corrosion happen there. So it's formed the oxides. It formed the oxides. Or it's, we can say, rust. Roasting is different and rusting is different. Remember. Okay. So old iron bars of buildings, copper vessels not clean for a long time, and then you can see that they on that metals will get one layer, reddish layer or greenish layer. So there, this is the corrosion. So now rusting of the iron articles causes large financial loss, thus cause corrosion of iron. That is, the rusting is a big problem. Now for removing this problem, or for avoiding this problem, we are coating these metals like as a iron nails you have seen. It is a zinc coated. We are getting it shiny. Actually, iron is not shiny color. Means iron metal don't have the shiny color. But if you see, when iron nails, it's looking at shiny color, silver color. That silver color means that zinc coating is done on it. Which zinc coating is done on it. So due to that reason, this we have to reduce to corrosion, or we have to avoid the corrosion. Then we are using the different types of methods to avoid this thing, as well as this we can say there calcination method is there. Then another one method you can see, tinning method, galvanization method. These are all methods we have to see here. Okay, so iron reacts with the moist air and deposit of the reddish substance Fe2O3H2 is formed, and this is substance is called the rust. Now there are so many examples. You will see there the copper cladded Statue of the Liberty made 300 years ago has turned green. Now there is so many reasons. Due to the pollution also, now we are getting this. So many those are things, historical places, historical, there are things, are objects are there. Now their color is changes. Now we can take the example of our Taj Mahal in Agra, is correct? So its color is already made up from the white color rocks, okay, or stones. But now its color is changing yellow color due to why? Because due to the more pollution, due to the more pollution, their acid rain form, and due to the acid rain, what happened? Its color is now changing into the yellow. Okay, you can search its information on Google, you'll get it. Okay. Now what happens when carbon dioxide reacts with the moist air and it forms there? Copper loses its luster, and then it's formed the one greenish layer, and this is called the copper carbonate, that is CuCO3. This is called the patination of copper. What is the patination of copper? That remember. Okay, copper reacts with the oxide, is formed the copper carbonate, and this is called the patination copper. Now here so many things are about. If you see, those people are living near to factory areas. Where those are living near to factory areas. If that places, those men or women, those are living there, they are using their silver ornaments. That silver ornaments will be converted into a black color. Its color will be changed into the black color. This is also one type of corrosion, and this happened due to the atmospheric condition, due to their air, due to their water. Okay. So now prevention of corrosion. How to prevent this corrosion? So simple thing first. With the help of their some layers we have to put on that metals, we can stop that. So what is there? That only we have to see. To fix a layer of some substances on the metal surface so that contact of the metal with moisture and air in the air is prevented, and no reaction would occur between them. If will not do that any painting, suppose nowadays we are using so many different objects, those colored iron objects are there. Okay, why they are that iron objects is color? Behind that only one main reason. If they will be in free nature, they will be contact with the oxygen or moist air, and they can form the rust. So avoiding these things, to prevent these things, we are giving the color to these things. Okay. Then another thing, sometime layer of paint, sometime oil, sometime grease or varnish on their surface. So like this, we can prevent the corrosion. Now, one thing, we cannot avoid or we cannot protect the permanently from rusting by painting them. Any object, any article, even though we are coloring it, but we cannot prevent it. So when that layer will be removed, immediately it will be start the rusting process. It will be start the corrosion process. So due to that reason, we have to paint it time to time. If we will not paint it, then after a few days, that object, it will be total rust, and it's whatever that metal, its luster and all things, it will be loose. Okay. So rheumatism we have to paint. Now, then corrosion can be prevented by the putting a layer of non-corrodible metal on a corrodible metal. This is can done by many ways. First one is their galvanizing. Galvanizing is what here? A thin layer of the zinc is applied to prevent the corrosion of iron or steel. To prevent the corrosion of iron and steel, we have to apply there one layer, that is zinc layer. Already I told you about the zinc. बघा आपल्या घरात बरेच जे ऑब्जेक्ट असतात नेल वगैरे असतात त्यांना काय केलं असतं असं सिल्वर कलर दिसतो आपल्याला ते ऍक्च्युअली सिल्वर नसतं तर तिथं झिंक कोटिंग केलं असतं आणि त्या झिंक कोटिंगमुळे काय होतं की तो ऑब्जेक्ट रस्ट किंवा त्याचा डायरेक्टली ऑक्सिजन किंवा मॉइश्चरवर कॉन्टॅक्ट येत नाही आणि त्यामुळे त्याचं करोजन होत नाही. So for the example of shining of iron nails paints you can see here. If you'll keep these iron nails for a longer time outside and after a few days if you'll observe it, then that shiny layer, that silver layer color, it will be removed from it by due to the atmospheric condition, by the moisture, and then afterwards it will convert into reddish color. So it is happening is due to the all corrosion. Okay, to avoiding this thing, what we have to do? Galvanizing process with the help of zinc. Now here you can see their caustic cleaning. First, we have to clean that metal. What is it? Suppose iron is there, then rinsing, then pickling, then rinsing here again, and plus solution. Whatever their solution, we have to keep it and then dry it, and then we have to give it zinc bath. Means we have to put in zinc solution, and then we will get after the cooling that metal. Now tinning with the help of tin metal. With the help of tin metal, we can do it. So in this method, a layer of molten tin is deposited on metals, and we can say it is a kalahi. It's given on the copper or brass vessels. जी तांब्याची किंवा पितळची जी भांडी असते त्यांच्यावर कलई केलेली असते. Now might be you don't know, but you can ask your parents, grandparents. They can tell you about these things. Okay, and this greenish layer is poisonous. See that? What is there? There one greenish layer is given formed on it, and it is a poisonous. If we keep in it buttermilk or curry, then it will be spoiled in it because due to this color and tinning is done to prevent all such damages. So suppose directly we keep in copper or directly we keep in brass vessel. That time what happen? It will be spoiled. So avoiding this thing, we are giving the color means that tinning process, and then all damages can be happen. Now anodization. What is by anodization? With the help of anode. With the help of anode and cathode, you know, no? Yes or no? Yes or no? Do you know anode and cathode? Who will tell me about anode and cathode? Repeat once again. Anode is positive charge and cathode is negative charge. Is it correct, other students?
Anode is negatively charged and cathode is positively charged.
Very good. So in this process, what happened? So like the metals, copper, aluminum are coated with the thin and stronger layer of their oxides by the means of electrolysis process. So here electrolysis process we are using their anode and cathode. So for this copper or aluminum article is used to anode as an anode means negatively charged, and oxide layer is formed on it, and then it is useful to prevention of their corrosion of this metal. So here one example is given when aluminum is anodized. The thin layer of aluminum oxide is formed. What is that? It's aluminum oxide. See that aluminum is anodized by the aluminum oxide, and that time it's formed one layer on that aluminum, and then it will be prevented from this corrosion. This is process is called the anodization. Remember this. It's maybe one short note question will be arise on this. It's very important thing. These all things galvanizing, tinning, anodization, electroplating, and alloying. These all things. Okay. Now electroplating means what happened there in this reaction. The less reactive metal is coated on a more reactive metal. Suppose we take the example of iron and zinc. Zinc is the highly reactive than the iron. We can coat it by the zinc. Okay. Silver plated spoons, gold plated ornaments are the examples of electroplating. Remember this. These are examples of the electroplating. Now alloying. Alloying means what happened? Can you tell me what is the alloy?
Alloy is mixture of one or two metals, more
Yeah.
than one.
Yes, very good. So alloy is the mixture of one or more metals are mix there, and then we can make their articles in which we can use. There are so many reasons. Now we are using their coins. Okay, that coins is made up from so many different alloys. If you see their color is different. Okay, even though we are getting these coins, suppose 1 rupees coin, 2 rupees coin in the silver coating. Okay, but it is made of one alloy. So which type of alloy that you have to find it. Okay, so what is the main intention behind it? That only to prevent the corrosion of metal. And while to performing this alloy process, that time they are making this homogeneous mixture. Homogeneous mixture means they mix with each other and they will not separate. Hetero mixture means they will not mix, they will show their differentness. But this homogeneous means they are one part. Okay. So for this, if you see there, 90% of the copper and 10% bronze tin is used for the bronze. Bronze, you know, no? Yes, bronze medal, sorry. So bronze statues do not get affected by the sun and air. Bronze statues, have you seen the statues? So it will be not affected by the sun and air. If you just use their copper, then it will be affected. Just we have seen the example of Statue of Liberty, and this is happening due to the only it's made up from the pure copper. It's not made up from the an alloy. So nowadays, when we are using this stainless steel, you will see their maximum vessels at our home. Those are made up from this. That is a if you see what is their alloy of the 74% of iron and 18% chromium and 8% carbon steel. Stainless steel. It's made up from the 74% iron and 18% chromium, and last one there 8% carbon. So these are different types of alloy we are using nowadays. So this coins is the one of the example. Then stainless steel is the one of the example. And do you know? Remember this just only very simple. When one of the metals is an alloy of the mercury is called amalgam. If it is made up from the mercury alloy, then it's called the amalgam. There are so many examples like the sodium amalgam, zinc amalgam, like this. Okay, silver amalgam was earlier used by the dentist. Now gold amalgam is used by the extraction of gold. So like this, we have completed here this lesson. If anybody is having any doubt, please you can ask me. Do you have any doubt about it? Yes or no? Please give me a reply. Speak fast.
No, sir, no doubt.
Now here, series.
It is a silvery white metal with an atomic number of 30. Its electronic configuration is 283 and its valency is 3. The main ore of aluminium is bauxite, Al2O3.H2O, which contains approximately 30% to 70% Al2O3, that is alumina. The remaining portion is made up of gangue, consisting of sand, silica, that is SiO2, iron oxide, that is Fe2O3, etc. Extraction of aluminium consists of 2 steps. 1. Concentration of ore, that is conversion of.
Already we have seen about this into alumina by the Beers process at temperature 140 to 150 degrees Celsius. Okay, and then we have seen after getting the sodium aluminate, then we are reducing its temperature up to the 50 degrees Celsius by 50, means up to 50 degrees Celsius, then we are getting it. Okay, and then Hall's process also same thing we are getting by the chemical reaction, and finally we are operating by the electrolysis method
Of bauxite into alumina by Beers process. 2. Electrolytic reduction of pure alumina to get aluminium. Step 1. Concentration of bauxite. Crude bauxite ore is crushed and then treated with hot concentrated caustic soda solution, that is NaOH solution in a tank called digester under high pressure for 2 to 8 hours at 140 degrees centigrade to 150 degrees centigrade. Aluminium oxide, being amphoteric in nature, dissolves in aqueous sodium hydroxide, resulting in the formation of water-soluble sodium aluminate. This process dissolves silica, that is SiO2, and alumina in aqueous sodium hydroxide, leaving behind undissolved iron oxide, that is Fe2O3, in the solution, which can be separated by filtration. The filtrate containing sodium aluminate and silicate is diluted with water and then cooled to 50 degrees centigrade. This gives gelatinous precipitate of aluminium hydroxide, that is AlOH thrice, leaving behind sodium silicate in the solution. This precipitate obtained is filtered, washed, dried, and ignited at 1000 degrees centigrade to get alumina, that is Al2O3. Step 2. Electrolytic reduction of alumina. This process is carried out in a steel tank, which is lined with carbon, graphite, that acts as the cathode. Hanging inside is a set of carbon, graphite rods that act as anode dipped in molten electrolyte. Melting point of alumina is very high, greater than 2000 degrees centigrade. Cryolite, AlF3, 3NaF, and fluorspar, CaF2, are added to alumina in order to reduce the melting point of the mixture to about 1000 degrees centigrade. On passing electricity, aluminium is obtained at the cathode. Being heavier than the electrolyte used, molten aluminium sinks to the bottom of the tank, from where it is removed periodically. Oxygen liberated at the anode reacts with carbon anode and forms carbon dioxide, due to which the depleted anode is to be replaced from time to time. Extraction of metals of medium reactivity.
So like this, we have seen how to obtain aluminum from the bauxite ores. So I think your everyone concept is clear here, correct?